Okay, today is June the 4th, 2018. This is Monday, and currently we have a temperature of 75 degrees here in the foothills of Los Angeles. We've got a relative humidity of 46.7%. The barometer is at 29.95 inches. We have a dew point of 53 degrees, and it's sunny, but we've got chemtrail haze in the skies over Southern California. And as we look at this northeast Pacific water vapor loop, we can see what's happening. We have a moisture field moving towards Southern California. There's actually low pressure indicated on the surface pressure map right in this area. And so we see some moisture moving in. We can take a look at some of these other maps. Let's go to the, let's see, right here. We've got the western U.S. Water vapor loop. We can see that moisture moving in right here on the IR map. So we've got the jets up spraying over this moisture field, and that will prevent any precipitation. Those chemtrails are very effective at capping the atmosphere and preventing precipitation here in the southwest. Now over here, over Texas, we have a huge thunderstorm system, which there are actually two systems merged. We can see the this area is being superheated. We've got some good evidence here. Let's take a look at the this is the central plains infrared map. We can see a huge hole opening up right here through the sequence. We can also see a blast pattern right up in this area. Here in the visible light map, we can see how this area is being evaporated. We see a sort of an angle down right through here as the sequence progresses. See some cutouts here, straight edge. And looking at the water vapor loop for the central plains, right here we can see that blast pattern. And over here on this the western U.S. map, we can get some good detail. You can actually see a pressure wave right down here at the bottom of this storm, shooting down to the south. This is a giant storm. It's probably about a third to about half the size of Texas. We can see that the storm itself was superheated. We see the blast pattern up on the northwest corner. We have a pressure wave leaving the bottom of that system, and then we see total collapse and evaporation. Looking at the scale down here, the colors tell us the depth of that water vapor right down here. We can see that towards the beginning of the loop, we're down on the pink range, which is fairly deep water vapor. And then towards the end, we can see an area trying to rebuild up here, and that'll be targeted later. But look at the evaporation pattern over the 7.5 hour loop. Now up here we have a developing gale. Now this is heading currently right towards California, right here, Central California. And that is a 999 millibar gale force system, which is currently heading towards California, but they've got it pointed towards Canada. So at some point, we will see this high pressure intensify and redevelop. We can see a sort of a blockade right here. And at some point, this gale right here is going to make a left turn, which is totally unnatural. This is the natural flow. We've got jet stream flow in this area, and we've got high pressure. Look at the clockwise rotation going on here. This is all unnatural. This is a transmitter generated high pressure zone, just as this is here. Now we've had very hot temperatures yesterday, and over the weekend, Saturday and Sunday. Saturday was about 86. Sunday was about 95. And prior to that, last Tuesday, Wednesday, Thursday, and Friday, there was a total of 3/16 of an inch of drizzle. So we had nice cool temperatures this past week. I didn't make any videos because I had things to do and there wasn't a whole lot going on weather-wise. But today we see an excellent example, once again, of the superheating process, where these thunderstorms are just literally superheated and destroyed. Now, on the playlist on this channel, I posted, or rather selected a video that deals with severe air turbulence. Take a look at that video and you'll notice the structure of the cumulonimbus cloud. It has been superheated. You can see the mushrooming of the top of that developing thunderstorm system. And there's a Boeing 777 flying through the area, transcontinental flight, and the person who made that video was had his camera looking out the window, and you can clearly see the development being superheated, and of course, depending on how much power is used to neutralize the storm system. Now, for instance, this one here, this is a gigantic storm, and so a lot of power was applied to create this massive evaporation pattern. And so we see that here. And so depending on the power that's used to disrupt these thunderstorms, that will generate a lot of descending air. You can see some good detail right here in the East Pacific water vapor loop. Look at that pressure wave exiting down to the south. And we see some thunderstorms developing down here in the eastern East Pacific. This is where the hurricanes are forming. This is where they form. Also right over near Acapulco. Look at this. See a developing system that's being superheated. We can see the blast pattern moving south and out of the northwest side there. And we see the evaporation pattern. Okay, we saw these. Right here we can get some good detail as well. So the video that's up in the favorites, that's a nice example of what happens when these thunderstorms are superheated. That generates a lot of descending air, a lot of wind shear, which affects any aircraft that are flying through the area. You know, when you have a descending air on an airfoil, the airfoil cannot produce lift. An airfoil works by generating low pressure on the upper side of the wing, and that's how planes fly, is by generating lower pressure on the upper side of the wing, and also, you know, so wind shear is a big problem, and that's a good example. Somebody got that on video. That's great. So I put that up on the playlist. Again, looking at the western U.S. water vapor loop, we can see that we're going to probably see higher temperatures all week long because of this incoming weather system. This will be blocked. We've got no rain in the forecast for the next several days. No rain, zero rain, but yet we've got a 999 millibar gale force. This is a very large system heading right towards California, but we can see that it's already being sort of steered right towards Canada and Washington State. And we can see the manipulation in this system right here, the evaporation on the frontal system. Satellite transmitters are at work here. We can see very little rotation in that vortex. Half of this moisture is missing. It should be wrapping around, just like you would see on a seashell, just a very tight spiral. We don't see that. So this is being manipulated and re-steered. We've got high pressure right here. Okay, so we'll just leave it right here. We can see that blast pattern right there. Look at that pressure wave we see total evaporation and collapse of that weather system. Okay, that's it.